This lesson is for Mrs. Cucci's College Now PreCalculus class. We are on lesson 5.5, circular functions, graphs and properties. We left off on page 1.22 and we started to talk about, we were going to start about talking graphing sine and cosine. Okay, so you need to make sure that you have graph paper out in front of you. You will be utilizing it. Preferably a ruler as well so you can draw your axes, and a pencil. Alright, so first let's talk about what a periodic function is. A periodic function is basically a function that repeats itself. Okay? So things in life that are periodic are the phases of the moon or tides. All of these things are periodic. Okay? Amplitude is another issue that we need to talk about. The amplitude of a periodic function can be defined as half the distance between the maximum and the minimum functions. Okay. How you can find it algebraically is by taking the maximum and adding the minimum to it and then dividing it by 2. So this should be maximum minus minimum divided by 2. I apologize. Okay. And that can be used if you're trying to determine if you're given the graph. So again, maximum minus minimum divided by 2. The sine function is odd. The cosine function is even. Those are just two things that you kind of have to keep in the back of your mind when we're going through this. And we've talked about even and odd functions, so this is nothing new. Alright, so let's take a look. We're going to do tangent, cotangent, cosecant, and secant as well. Okay, so let's first talk about sine. Okay, so we're going to graph it. I would like your axes right down the center, and we're going to be going on the interval from negative 2 pi to 2 pi. So if you remember from last year breaking this up, we know that 2 pi will be at our very end. Half of 2 pi is pi, so we can split that right in half. Half of pi is pi over 2, and then this is going to be 1.5 pi, so 3 pi over 2. Same thing's going to happen as we go to the left of our origin. Okay, and we will start with our sine function. Alright, so we're going to start with our basic sine function. Okay, we know that when we're going through this, we're basically going to use our knowledge from the unit circle to find out where these functions are equal at each degree or rotation. So we know this is the point 1, 0, 0, 1, negative 1, 0, and 0, negative 1. We know sine is our y coordinate. So at 0, here's 0, sine is 0. So we start right at the origin. Okay? At pi over 2, sine is 1. So I'm going to go up to 1 here. At pi, we're down to 0 again. At 3 pi over 2, we're down to negative 1. And then 2 pi, we're back to 0. Follows a trend if I go in the opposite direction as well. Negative pi over 2 is going to be negative 1. Negative pi is 0. Negative 3 pi over 2 is 1. And negative 2 pi is 0. So when I sketch this in, whoa, I'm a little off. I get this trig function. Okay, so sine kind of looks like a sideways up. Okay, so likewise, we're going to also take a look at cosine. Okay, now from this, just so we're aware, I do want to talk about amplitude because we discussed it in the notes. The amplitude is 1/2 the distance between the maximum and the minimum. The maximum is 1, the minimum is negative 1. Okay, so it's half of that distance. So half of the distance, we've got 1 unit and then 2 units from here to here. Okay. Half of that would be 1. So again, we said the other way you could do it is max minus min divided by 2. And again, this is for amplitude. Okay. My maximum is 1 minus my minimum, which is negative 1 divided by 2. Minus negative, we get plus. 2 divided by 2, which I know to be 1. Okay, so there's your amplitude. All right, so let's take a look at cosine. Okay, so we're going to look at cosine here. Okay, and again, we're going to go from that unit circle. So here's our point, 1, 0, 0, 1, negative 1, 0, 0, negative 1. Cosine starts at 1. I guess I should have the 1 and negative 1 here. At pi over 2, it goes down to 0. At pi, it goes down to negative 1. 3 pi over 2, back to 0. And 2 pi, back to 1. Going in the opposite direction, cosine is 0. And then negative 1, 0, 1. So we can go ahead and sketch that in. My sketches are a little ugly today, sorry about that. And here's our cosine curve. Okay, so again, we can look at our amplitude. Remember, amplitude is halfway between, it's half of your maximum minus your minimum. So max minus min divided by 2. Your maximum again is 1, and your minimum is negative 1. So we get 2 over 2, which is 1. So our amplitude again is 1. Okay? All right, so this is your cosine curve. All right, so I want to look at some connections between sine and cosine. Okay? Let's see if I can squeeze them on both page. Not quite. Both of these functions are continuous, and both of them have a period of 2 pi. Period means how long it takes to get one full curve. So if I look at this here represents one full curve, going from maximum to maximum. Okay? So the period would be 2 pi. That's how long it takes. Your domain is going to be all real numbers, so we're going to use every value along that x-axis. The range for both of these is negative 1 to 1, so those are the values they oscillate between. The amplitude for both of these is also 1. So they have a lot in common. The only difference really being that cosine and sine are simply translations of one another. They've been shifted over 90 degrees, essentially. Okay? All right, so the next thing I want to take a peek at is I want to take a peek at the graphs for tangent, cotangent, cosecant, and secant. Okay? And I kind of want to do it based off of, for at least cosecant and secant, the original graphs of their reciprocals. So let's start with our sine, okay? And we are going to do this, I'll do it in green. We're going to do cosecant. Now remember, cosecant is simply the reciprocal, okay? So all I'm going to do is I'm going to take the values and what it's equal to at that value and come up with the function value for the reciprocal. Okay? So cosecant, the nice thing about this is it's actually pretty simple. All right? We knew that sine at 0 was equal to 1. Okay? That means cosecant at 1. Oops, sorry about that. Hold on a second. Okay, so cosecant, we have to remember, is 1 over sine. Okay? So at 0 degrees, I know sine is 0. So we get this 1 over 0. Okay? So what that tells me for my inverse is that this is going to be an asymptote for me. Okay? So everywhere sine was equal to 0, for cosecant, it's going to be undefined. You're going to get that vertical asymptote. All right, so I'm going to put all of those in now. All right. Now, if I want to go a little bit further, let's talk about cosine at pi over 2, or sine at pi over 2. So sine at pi over 2, I knew was 1. Cosecant at pi over 2 is going to be 1 over 1, which is still 1. Okay, so I'm going to get a point here. Now, what's going to happen is, with cosecant, everywhere you get a -1, cosecant's going to be 1, or -1. Everywhere you get a 1, cosecant's going to be a 1. Okay? So we have these points here. Remember, asymptotes kind of draw a function in and guide it along. So what you wind up getting for cosecant is something that looks like this. Okay? And there's your graph for cosecant. Okay? So, same thing is going to happen with secant. So let's take a peek at that. Again, everywhere cosine is 0, secant is going to be undefined because it's going to be 1 over it. So it's reciprocal. Okay? So wherever you have those zeros, you're going to put in vertical asymptotes. Right? Everywhere you have a maximum, you're going to have a point. Everywhere you have a minimum, you're going to have a point. Same kind of idea. Same general look. Again, it's simply a shift of 90 degrees, a translation. Okay? And there's secant. Okay, so the last one we're going to take a peek at is tangent. Oh, yeah. Okay, so now we're going to talk about tangent. Remember, tangent is your ratio of sine over cosine. So what's going to wind up happening here is we need to pay attention to this here. Okay? If cosine is 0, what winds up happening is we get undefined. Or, as you guys know, what that means is a vertical asymptote. All right? So everywhere cosine is equal to 0, we get that undefined. So we know cosine is 0 at pi over 2 and 3 pi over 2 and negative pi over 2 and negative 3 pi over 2. Okay? Now, tangent at 0 is 0, sine over cosine, right? Sine is 0 at 0, cosine's 1, so it winds up being 0. Okay? At pi, it's going to be 0. At 2 pi, it's going to be 0. At negative pi, it's going to be 0. And at 2 pi, it's going to be 0. So we get those zeros. Now, tangent, if I think about it, pi over 4, 45 degrees, okay? We know at 45 degrees, we get the point square root of 2 over 2, square root of 2 over 2. Again, tangent is sine over cosine. So at 45 degrees, which will be right here, halfway in between pi over 2, it'd be square root of 2 over 2 divided by square root of 2 over 2. Anything divided by itself is 1. All right? That's in the first quadrant. In the fourth quadrant, if we're moving in this direction, tangent is negative. So we're going to get a negative 1 here. And what we wind up with is this function that kind of looks like this. Okay, and it extends up to negative infinity and down to, or up to positive infinity, down to negative infinity. And it follows the same pattern for each section here. Okay. So it looks like this. There's tangent. Now tangent's reciprocal is a little bit different. So with tangent's reciprocal, our asymptotes are going to be changed. Okay? Instead of having asymptotes at negative pi over 2, and so forth, you're going to have asymptotes now where sine is equal to 0. So you're going to have asymptotes at 0, at pi, at 2 pi. That's where sine is equal to 0, right? At negative pi and at negative 2 pi. Okay? And then my zeros are going to become where my asymptotes for my original function were. So here. Okay. And my function is actually kind of going to be flip-flopped here. So here's y equals cotangent. Okay. All right. So there we have tangent and cotangent. All right. So please come prepared with any questions, and I will see you guys tomorrow.